Okay, so again, this picture is very informative, and it gives you the full view of your study as a computer engineer. It gives you the full picture. Okay, so when you start studying fundamental of electronics, okay, you were at the transistor level. You studied how to make gates, right? You remember how to make gates, how to make AND gate, OR gate, or any gate of any functionality. Okay, so you start from there. Based on that, or in parallel to that, you study also logic design. Logic design is also, it's at the, let me get the pen, it's at the sort of this level, going vertically. It goes sometime to circuit, it goes up to the digital design. So you have to learn in fundamental of electronics how to make a gate, and later on you, or even before that, you go to digital logic design to actually use this gate to build bigger systems and bigger blocks like adders, subtractors, multiplexers, decoders, multipliers, etc., etc. Okay, so in fundamental of electronics and in digital design, you start here. Circuit analysis, circuit analysis 1, you are at the transistor level, you are at the circuit level. Okay, that's what, this is your foundation. Okay, and then you go up, you go up to the block level. Okay, these courses are not necessary in order. So for example, programming at this level, operating system at this level, embedded systems and microcontroller at sort of this level. Combining the two levels, you have the separation between the software and the hardware. So in the embedded or in the micro, you learn how to program. Okay, you have to have some knowledge of the hardware, some knowledge of the IO, the addresses of the IO in the case of the embedded system, so that you can communicate with the with your peripherals, or with the microcontroller peripherals. Okay, you have to know your instructions, the instruction set for the in the micro. Okay, you have to program using the micro. Okay, so all of these are sort of blocks that clarifies why are we doing what we are doing in that order. Okay, and how we are building all these blocks. Now, in the case of the computer architecture, and in the specific case of computer system architecture that we are studying, actually you have to sort of, you have to have the foundation. You cannot study computer architecture without the foundation. Okay, we are going to work on these, how to build the data path and how to build the control path for a computer. So this is going to be a main focus in computer architecture. That would be 2 chapters of our curriculum, okay, or of our course. Okay, so then we are going to, when we go into the higher level, we might work on this and the instruction set architecture. This is going to be a major part of our course as well. We are going, we might touch a little bit on the IO system, but not that much. Okay, and then we might look at the full view. So that's my here, this whole thing, this whole block in green is, you can say, is our course. I might talk a little bit about the compiler, I might talk a little bit about the firmware, I might talk a little bit about the application, but that's basically our focus here in the heart of your studies, so that you connect what you studied in the application and the operating system, whether it's C or Java or whatever, into the foundation that you studied so far in the digital design, in the DLD and circuits and the fundamental of electronics, and etc., etc. Okay. Now, the computer, this course is going to be in the heart. So sometimes we are going to go into the software, the instructions, and sometimes we are going to talk about the assembly instructions. Sometimes we are going to talk about the C code and how does it translate into my assembly for a specific hardware. Sometimes where we are going to spend so much time on designing the full computer, and why do I need such computer, and why do I need anything other than digital logic design. In digital logic design, we learned how to design basically any logic block. So why do I need the computer architecture? Why did people invent microprocessor? All of these questions we are going to answer in this course. Okay. Perfect. So this picture again, no, the instruction set architecture is your micro assembly language, meaning that what are the instructions that you are using, what type of instructions do you have, what type of registers do you have. All of these are, so anything that's seen by the user is called instruction set architecture. Okay, which means registers, what are the general registers that you use, what are the instructions that you have. Do you have a multiply instruction? Do you have add instruction? Well, you have to have an add instruction, but multiply, divide instruction, all of these instructions. Okay, now I only need to know this information in order to work in the firmware, in order to work in the compiler, in order to work on the operating system and in the application. I don't have to know the hardware details. Okay, that's why we have this sort of abstraction level. What does abstraction means? What does abstraction means? Abstraction means when you abstract the data, that means you hide some of the data. Okay, exactly. So hiding the data, meaning that I am trying, my voice is not clear. Please, you can refresh, try to refresh. My voice is lagging. Okay, then I am going to stop and start again. Will that work? Is it still lagging?